Welcome to This Explainer. If you're building or scaling AI today, you already know we are way, way beyond simple chatbots. Today, we're unpacking some seriously brilliant research by Dr. Nabanita Sinha on governing modern enterprise AI systems. And trust me, this framework is exactly what you need to understand to keep those advanced systems from going off the rails.
I mean, think about it. You wouldn't let a team of human employees just go off and execute high-risk, complex tasks without a manager or clear guidelines, right? So why on earth would you let autonomous AI do it? We are looking at a night and day difference from early AI. We've moved away from those basic, narrow, single models that just sat there waiting for your prompt. Now, we've got incredibly dynamic, multi-agent ecosystems. We're talking systems that collaborate, plan, and literally trigger external software entirely on their own.
But, with all that incredible autonomy comes some pretty amplified risks. The reasoning chains behind how the AI makes a decision become totally opaque. Bias doesn't just sit in one model anymore. It spreads like wildfire across multiple agents. Traditional governance frameworks simply weren't built for things moving this fast. Which brings us to the solution, the Trace framework. Instead of treating governance as an afterthought or, some static PDF manual nobody reads, Trace actually embeds governance directly into the system's architecture. It becomes an active, enforceable control. It's a real game changer.
The whole framework is built on 5 core pillars: trust, review, accountability, critique, and explainability. Together, these ensure that every single agent in your system remains a governable entity, no matter how autonomous it gets.
Okay, so how does this actually work in practice? Well, Trace organizes multi-agent AI into a strict, interconnected 3-layer architecture. Let's break down exactly what's happening under the hood. Layer 1 is governance and compliance, the policy brain and protective shield. This first layer acts as a very strict security checkpoint. By validating data, masking sensitive PII, and enforcing rigid access controls, it makes absolutely sure no agent operates outside legal boundaries. It literally stops rogue behavior before the AI even begins to reason. Next up is Layer 2, the operational agent layer, the agentic orchestration engine. Now, this execution core is super fascinating because it handles 2 totally different setups. You've got adaptive ecosystems where agents dynamically evolve based on context, and then you have prescriptive workflows that follow rigid, predefined steps. But in both cases, every single action is strictly observable. The big takeaway here? Autonomy is fully enabled, yes, but it is never opaque. Every external tool call, every little reasoning step, emits telemetry. So execution quality isn't just blindly assumed by engineers, it is constantly, actively measured. Which brings us to Layer 3, the oversight and assurance layer, the built-in auditor. Right at the heart of this layer is what's called the critic agent. Think of it like an independent inspector. It runs automated critiques on other agents before any final action is taken, basically ensuring that decisions are factually grounded and logically sound. And this is absolutely crucial. If risk spikes or confidence drops, this layer hits the brakes. It seamlessly kicks the decision up to a human. These human-in-the-loop checkpoints give you the ultimate override authority to keep the system safe. As Dr. Sinha points out in the research, autonomy remains powerful, but accountability remains enforceable. It's honestly the perfect balance. You get the massive scale of autonomous AI, but without sacrificing enterprise accountability. So, you might be wondering, how do we actually measure all of this? The framework uses something called OSC, or Overall System Confidence. It's a unified score aggregated directly from the evaluation signals across all 3 of those layers we just went through. This score acts as a hard threshold. High confidence? Boom, automated execution is a go. Medium confidence? Hang on, human review is required. Low confidence? The system blocks the action and triggers retraining. It takes this vague idea of trust and turns it into a hard, defensible metric. Now let's tie this all back to reality. Because for any enterprise, this is the part that really matters. Global regulatory expectations around AI are tightening incredibly fast. Regulators behind major frameworks, we're talking the EU AI Act, ISO standards, the NIST AI Risk Management Framework, they are all demanding controlled, explainable AI. Trace takes those exact expectations and bakes them right into the architecture. Honestly, if you look at it, Every single letter in the TRACE acronym directly satisfies a core regulatory requirement. From preventative risk controls under trust all the way down to structured summaries in explainability, it covers the whole shebang.
A quote from the source material really hits the nail on the head here. Regulators don't ask whether AI is innovative. Innovation is fantastic for your business, for sure, but strict compliance is mandatory for your survival.
At the end of the day, Trace bridges the massive gap between a company's high-level policy goals and actual runtime enforcement. In these complex ecosystems, it replaces subjective trust with verifiable mathematical assurance.